Okay, thank you. So today's presentation is going to consist of three parts. The first part will be me giving my understanding of IBM's vision for systems engineering. The second part will be their vision specifically for Watson for systems engineering. And the third part will be looking at one of those Watson for systems engineering use case, what we call use case 1, their cognitive requirements assessment. So for the beginning, in terms of systems engineering, IBM and Boeing's view is that systems engineering is becoming increasingly important because our products are becoming more complex. They're becoming more instrumented, more interconnected, more intelligent, they have more functionality, and they have more software. So we have to do things better. So what these new products look like is that we have a product. That product is now being more and more instrumented. It's being instrumented both internally for more self-awareness, self-knowledge of the product itself, and externally becoming more aware of its environment. It's also becoming more connected. It's becoming more connected internally, so it's aware of its parts talk to each other to a decreasing degree, and externally, it's talking to other parts. Plus, it's now connected to cloud-based servers, sending the information it's gathered up to a cloud storage facility, where that information is then analyzed for insight and knowledge, both through big data analytics and through cognitive processing. And then the results of that insight and knowledge get shipped back to the product, where we apply cognitive processing and the products become smart and act in an intelligent way. All of which dramatically increases the complexity of the product and dramatically increases what we have to do as systems engineers. So how does IBM approach this problem? Well, IBM says there's three areas that we need to work on. One is model-based systems engineering. Secondly, we have the Internet of Things. And the third one is cognitive processing. So to handle those, IBM proposes a set of tool suites of IBM Jazz to handle the model-based systems engineering, their IBM IoT to handle the Internet of Things, and IBM Watson to handle the cognitive processing. But IBM is not just presenting those three products as isolated products. They're working out the interfaces between those products to enhance the capability. So one of the things that you want to do is take your model-based systems engineering environment where you design your products and design them for the Internet of Things. So design the Internet of Things capabilities within your products, and to enhance our ability to do that, they have their IoT workbench. Secondly, you want to take the information you're gathering from the Internet of Things connectivity and cycle that back into your model-based systems engineering environment, and they have their DevOps approach. Thirdly, you want to take your cognitive processing abilities and apply that to the Internet of Things, and you have Watson Analytics, and you want to take the information you're gathering from the Internet of Things and do cognitive processing on that to gain knowledge and insight, and you have cognitive IoT. Then you want to take your cognitive processing and you want to design your product to take advantage of cognitive processing, embedded cognitive processing, and other cognitive processing. You have Watson as a service. And finally, you want to take your cognitive processing and apply that to your engineering process, and you have Watson for systems engineering. So that's kind of the overall view that IBM takes, is how we go forward with systems engineering. Now, what we're going to talk about